Hello everyone, greetings. This is Vignesh, working as an assistant professor in Department of Mechanical and Mechatronics Engineering in SNS College of Technology. So in this lecture series, we are discussing about the basics of civil and mechanical engineering. And in my previous videos, we discussed about the basics of surveying and basics of chain surveying. And from this, in continuation, we are going to discuss about the basics of compass surveying. So, have you anyone experienced that while traveling in a highway or whether traveling, have you seen some people holding the tripod and camera kind of a thing, and some people with after some distance holding the rods kind of a thing, right? So what they are doing is like they are doing the survey, that too, that is compass surveying. We thought or something that they are doing some fancy things. No, they are not doing the fancy things, they are doing the compass survey. So in previous video we discussed about the chain surveying, right? So chain surveying can be used for a smaller area or regular or flat surfaces. What if the surfaces are irregular or not flat? So for that, we can use the compass surveying. That is why the highways or other areas where the compass surveying are effectively used for measuring the lands. So compass surveying is a specialized branch of surveying that combines angular measurements using compass with linear measurements using chain or tapes. So nowadays, instead of chain, we are using tape. So both chain or tape will be used for a linear measurements, and for angular measurements, we definitely want to use the compass. So this method becomes essential when dealing with larger areas containing obstacles or uneven terrain where traditional chains are not even possible to use. So the technique focuses on measuring the magnetic bearings of survey lines to accurately locate points and create detailed maps. So all these maps, constructions, everything with the help of surveying alone we have to do. So this approach allows surveyors to navigate complex landscapes efficiently while maintaining the precision required for professional mapping projects. So, unlike simple linear measurements, compass surveying provides the angular data necessary to establish a precise position across a varied topography. So, once the topography is not as simple as that, we need advanced technology. Nowadays, we are using drones, but effectively, the compass is also used here for angular measurements. So the principles of compass surveying is called as traversing. Like first one is a forward bearing. So the measurement taken in the direction of survey progress, only the forward direction is called as a forward bearing. Once the measurement taken against or opposite the direction of a survey progress is called a back bearing. It is for error checking and accuracy. So forward and back bearing should ideally differ by exactly 180-degree, confirming that measurement accuracy. Once the value has changed, then automatically we need a verification process. Either we have done mistakes in forward bearing or in a back bearing. So traversing forms the backbone of compass surveying by connecting survey points through a series of straight lines. So this systematic approach, enables the users to map larger or irregular areas efficiently. So the dual bearing system provides built-in quality control, ensuring reliable results even in challenging field conditions. So it is used mainly used for a terrain kind of a thing. So once the terrain is very difficult to measure, we know that, right? For this, the compass surveying can be used effectively. And the tools or types of compasses, like we have prismatic compass, we have surveyor's compass. It is a easy one. As I said, it is a tripod mounted. We have seen in real world cases. And magnetic compasses. So in prismatic compass, it has a built-in prism, enables a simultaneous sighting and reading. And it surveyor's compass, we don't have a prism here. It measures the horizontal angles precisely, and it is ideal for detailed topographic work. And magnetic compass, basic compass with magnetic needle, aligns automatically to Earth's magnetic field. So simple operation and maintenance, suitable for general orientation task. So each compass type serves specific surveying needs and offers different levels of accuracy. And the choice of depends on project requirements, terrain conditions, and desired precision levels. So the advantage, like uh, especially large areas filled with obstacles and rough terrains, these can areas can be highly or effectively measured with the help of the compass surveying. And susceptible to magnetic disturbances from iron ore deposits, electrical cables, and metallic structures that can affect accuracy too. It is kind of a limitation. And it reduces the precision, like less accurate measurements near magnetic anomalies, as we said, like requiring careful site assessment and alternative methods when necessary. So understanding the measurements, understanding these advantages and limitations is crucial for selecting the most appropriate surveying method for each specific project. We are discussing, right, till this series, that once if you know about the land area, only after that you have to select the how to measure those area. So the terrain, if it has high obstacles or terrain is no uh, very uh, complex or not easy to measure, for that we need to use the compass surveying. Okay. So once the terrain is flat, it has less obstacles, then you can go for the chain surveying. So successful compass surveying requires careful consideration of environmental factors and potential sources of magnetic interference too. So understanding these concepts is very essential once you are going for the surveying. And this is Vignesh. Thank you for watching.